Okay, so extinct animals can be studied using their fossils. 70-million-year-old fossils from the Tyrannosaurus rex and Triceratops dinosaurs show that a Triceratops was sometimes eaten by Tyrannosaurus rex. The diagram shows a Tyrannosaurus rex skull. On the diagram, the position of the main biting muscle is indicated by the labelled muscle force. The muscle is connected to the point at J. This produces a moment about P when the jaw is hinged. Teeth marks shown in the Triceratops bone show the force exerted by a tooth in the front of the jaw could reach 60,500. The skull is drawn to a scale of 1 to 10. The force arrows are not drawn to scale. Take measurements from the diagram to determine the size of the muscle force when the force exerted by the tooth is 6,500. Well, first of all, the diagram here I think is a little misleading because this is showing if we had some object here. This is the force on that object. The force on the jaw would be the other way, right? If you had some object, you'd be squashing the object. The object would feel a force that way, but the jaw would feel a force the other way. But we don't need to worry about that for this question in particular. The reason you might have been confused by that is actually both of these forces appear to turn it clockwise, which of course is not the case. This one is turning it clockwise, and the force here would actually be turning it anti-clockwise. Okay, anyway, so we're going to use that idea that the moment of a force is a force times a perpendicular distance. Moment is equal to the force times the perpendicular distance from the line of action of the force to the pivot. Well, the pivot was point P. It says it down here, about point P, where it is hinged. So this is the pivot. So X, if you look, is already perpendicular. This distance is 13.5 centimetres as my perpendicular distance. But this force is not, that distance is not perpendicular. So we need a distance which is perpendicular. So the way to do that is to put your ruler perpendicular, if you like, put your ruler perpendicular to that muscle force. I'm sliding it up and down perpendicular, and you can see that it is the perpendicular distance is actually here. This is where the distance, this is the force this is the distance which is perpendicular to the line of action of the force. And if I measure that length there, that length is about 3.7 centimetres. Now I know they've given us it lovely and to scale, but actually that scale is going to cancel. It says it's drawn to a scale of 1 to 10, so that's actually 1.3 metres, and that is 3.7 metres, but the scale will cancel. So it's actually a lot simpler than it seems. You don't need to involve the scale. Let's do the calculation then. So moment of muscle force which is clockwise moments need to equal the anti-clockwise moments. The moment of the muscle force must equal the moment of the force times on the tooth, moment the force on the tooth, which I've already said is actually the other way, just a little bit confusingly, in that direction. So the moment of the muscle force, let's just call it force, times the perpendicular distance, 3.7, is equal to 6,500 times 13.5. So F is 6,500 times 13.5 over 3.7. 6,500 times 13.5, 13.5 divided by 3.7. I lost my decimal points for some reason. Giving me 23,700 newtons. Okay, so that's my answer. 23,700 newtons. Okay, there we go.